Hello and Namaste. In continuation with the Z transforms, we are going ahead with the different properties, and today's session we will be going ahead with the Z transform of n to the power k and Z transform of t to the power k. Now these are the two functions which we are dealing here with. Out of that, the first one, Z transform of n to the power k, is nothing but Z transform of this n to the power k. K can be written as 1 into k minus 1 plus k minus 1, that is n into n raised to k minus 1. If we'll observe here, which is this n into n to the power k minus 1, this is nothing but we can follow it from the differentiation of the z domain. Wherever we are multiplying with the n to the function, it is giving us the formula minus z d upon dz of f bar of z, or you can say the z transform of f of n. Now, if you observe here in this case, we have got this n into n to the power k minus 1, that is minus z d upon dz of z transform of n to the power k minus 1, which is also known as the recurrence formula for a z transform. Now, this is after that we can go ahead and find out the z transform of just n, that is when the value of k is equals to 1. So, if k equals to 1, then we have to find out z transform of n, that is minus z d upon dz of z transform of 1, and we know that which is nothing but is equals to this z transform of 1 is giving us the value as minus 1 upon z minus 1 the whole square, which is nothing but z upon z minus 1 the whole square is coming out to be z transform of n. Now, z transform of n square is nothing but minus z d upon dz of z transform of n. So, it is nothing but what will happen if k is equals to 1, what will happen if k is equals to 2. So, it is nothing but by induction we are trying to prove this, the z transform of n to the power k, and making the results generalize. So, z transform of n square is nothing but this, which is giving us minus z d upon dz of z upon z minus 1 the whole square. So, this is nothing but 1 upon z minus 1 the whole square, which is giving us the differentiation. We will be going ahead with the differentiation, that simple u by v rule with respect to z we are differentiating with. After that, the simple you can just have and just try to fill it up, this particular u by v rule. You will be getting it z into z plus 1 upon z minus 1 the whole cube. Similarly, z transform of n cube is nothing but z into z square plus 4z plus 1 upon z minus 1 the whole to the power 4, and so on. This is what we have to just take the value of k is equals to 3, and we'll be getting the values as so on. So, by the mathematical induction we can prove this, and we can find out the z transform of n to the power k, and k might be any number over here. So, this is about n to the power k. Now, what will happen if z to the power z transform of t to the power k, that is z transform of n into t. So, we have already seen that t is nothing but n into capital T. T is a period of that particular function, and that is nothing but in this way. Here we can go ahead, and as we are aware of this particular property, t is a constant, so t to the power k will come out of the z transform, and we'll be having this z transform of n to the power k, that is minus t to the power k into z upon d upon dz, z to the power n minus k, which we have just now n to the power k minus 1, what we have done it in last section or last slide. The same way we can go ahead and just keep on doing this particular thing. We will be going ahead with the proof of this. So it's nothing but the z and t will be getting club over here, and we'll be getting this value something like this. That means we'll be getting this particular value as this. So, this is z transform of t to the power k is minus t z d upon dz of z to the power t minus t to the power k minus 1. Now, again, if t, the value of k is equals to 1, then that means what this particular value, so we will be replacing k, the value of k is equals to 1. So, we will be getting z transform of 1. That means minus t z d upon dz of z upon z minus 1, which is the z transform of 1. And therefore, we can just go ahead and just simplify and do u by v rule for this d upon dz of z upon z minus 1. We'll be getting tz upon z minus 1 the whole square when the value of k is equals to 1. Similarly, when the z transform of t square, that means the value of k is equals to 2, the same formula k is coming out to be 2 here, we'll be getting the value of z transform of t square as, because it's z transform of t to the power k. So, if you'll observe here, this is t to the power 1, z upon z minus 1 to the power 2, that is k plus 1. Similarly, here if you'll observe here, this value of k is equals to 2 here, so it's the value of k here, and this is nothing but this 3 is nothing but k plus 1. Similarly, when we have got this k equals to 2, we will be having z into z plus 1 upon this. And similarly, when k equals to 3, we'll be having z transform of t cube as t to the power 3 z into z square minus 4 plus 4z plus 1 upon z minus 1 to the power 4, and so on. So this is by the induction, mathematical induction, we can go ahead and make the generalized results for the z transform of n to the power k and z transform of t to the power k in short. Yeah, this is all about this particular property. Thank you. Happy learning.